All right, linear versus quadratic model. So we haven't talked about linear equations in a while here, but now we're ready to go back. A linear equation, remember, we would write that in the format of y is equal to mx plus b. Now, in this case, I know that y is saying, like, if I input any value on my y-axis, and x, if I input any value on my x-axis, I could solve for things. However, m and b, those represent the slope, our rise over our run, and b represents our y-intercept. So where is our starting point? Y-intercept. This equation in particular has a starting point at +1, and the slope would be 1. Quadratic equations, they come in the format y is equal to ax squared plus b of x plus c. When we are graphing them, we could also find the axis of symmetry using the equation of x is equal to negative b all over 2a. And once we know the axis of symmetry, we use that to help us find the vertex. Here you're asked to do some graphing and determine whether what we have is linear or nonlinear. So if it's a straight line, I know it's linear. If it's not and it loops, it's a quadratic. So I'm going to graph a few points, -2 down 7, 0, -3, 1, -1, 3, +3, and 5, 7. All right, it is linear. And now what is the equation? So I know my slope is positive because it increases as I go from left to right. I see that the y-intercept is 0, -3. My table also tells me this here. Like when x is 0, what is y? My slope is my rise over my run. I rise 2, go to the right 1. Rise 2 to the right 1. So my slope is 2. Y is equal to 2x, and our y-intercept is -3. Just a side note, not that you have to do that, but you could also take a pair of points and say if you want to deal with these here, 3, 3, 5, 7. If you didn't have a graph, I just want to remind you that it's the change in y over the change in x that you could use to find the slope. So 7 take away 3 is in the numerator, and then 5 take away 3 would be in the denominator. 4 over 2, and that would simplify to 2. So your slope is 2. All right, so now this problem over here, -3, 2, 1, 2, 3, -2, -1, -1, -2, 0, -1, 1, 2. Okay, so clearly this is not a line, which makes it a quadratic. There's a parabola here. It is curving. I know it's positive. And when I look at this, my axis of symmetry, I'm going to draw a dotted line here, is at -1, -2. -1, -2. So I'm going to go ahead. Y is equal to x squared plus 2 of that, 2x minus 1. And you're probably wondering, okay, well, where did that equation come from? So I'm going to go over how we write these equations today when we're in Google Hangouts. What I want you guys to do is focus on like being able to at least spot the ones that are linear equations and remind yourselves how to graph. The one thing that helps to look at is knowing that your starting point is your y-intercept and knowing that that is the value you're either adding or subtracting at the end.